Okay, let's look at momentum and impulse. We will be looking at collisions today. We will be focusing on collisions, where we will try to figure out what happens during a collision. Okay, let's look at this example. We have a small truck. Yeah, we have a small truck. I will label it truck A. It's a small truck A and a large truck B. These two trucks are approaching each other and they eventually collide. These wavy lines are just to show you that they have collided. There was a collision that has occurred. Truck A approaches truck B and truck B approaches truck A, and they eventually collide. So when these two trucks collide, they exert forces on each other. Forces on each other. This truck A exerts this force, which is a force on A by B. This is a force exerted on this smaller truck by B, and then this one is a force on B by A, a force on B by A, a force on B by A. So now the forces that act on each object during a collision only act for a short period of time, for a short interval of time, and they change the momentum of each object. They also change the momentum of each object. So now let's look at how do they change the momentum. When these two objects collide, there is a change of velocity. If this bigger truck was approaching the smaller one at a velocity of maybe 20 meters per second, immediately they collide, that 20 meters per second is going to change. It's going to change. Now, we know that momentum is equivalent to the product of an object's mass and its velocity. But now in this case, instead of just having velocity, we now have a change in velocity. We now have a change in velocity. And this change of velocity, if we are to distribute this whole thing, we will result with the product of an object's mass multiplied by a change in velocity. Is usually the final velocity, subtract the initial velocity. What's our final velocity? Our final velocity is the velocity after the collision, and our initial velocity is the velocity before the collision. So when we have this, we will have when we distribute this, we will have an object's mass multiplied by its final velocity, subtract the very same object's mass multiplied by its initial velocity, the velocity after the collision and the velocity before the collision. So now if you look at this term here and you also look at this term, if you look at those two terms, they take us back to the original momentum formula, meaning that we will have something we call our final momentum. This will be our final momentum when the final velocity, when the product of the final velocity and the mass of the object will result in a final momentum. Then we will subtract the initial momentum. So if you pay full attention to this change in momentum, to this momentum, this is now a change in momentum, which is actually equivalent to a change in momentum. And this is due to these forces. This is due to these forces that occur during a collision. And mind you that the force that this larger object exerts at this smaller truck and the force that this smaller truck exerts at this larger truck is equal. They just exert forces of equal magnitude in opposite directions. This is according to Newton's third law. Newton's second law. This is according to Newton's second law. Now we have a change in momentum. Let's now go and attempt to do a question. This is just the information that I would think is necessarily enough for you to solve the following questions. Okay, let's look at this question. You can pause the video and attempt to do the question by yourself, or you can just watch as I go through this question. A tennis ball with a mass of 60 grams is traveling horizontally at 15 meters per second. The ball is struck by a racket and moves horizontally at 20 meters per second in the opposite direction. This means that this ball has collided with this racket. And now that this ball has collided with this racket, it means this 15 meters per second is our initial velocity, and this 20 meters per second is our final velocity. The velocity 15 meters per second is the velocity before collision, 20 meters per second is the velocity after the collision. Now, they say, what is the magnitude and direction of the change in momentum of the tennis ball? We are looking, let's look at the variables that we were, at the values and the variables that we were given. We are currently, they say we should calculate the magnitude and direction of the change in momentum. We are currently looking for a change in momentum. This is our unknown. This is what we are looking for. And the mass for this object is said to be 60 grams. But we know in physics, we do not work with grams, rather we work with kilograms. Meaning this 60 grams will be multiplied by 10 to the power negative 3 so that it ends up being 0.06 kilograms. And then our initial velocity before the collision is 15 meters per second, and our velocity, our final velocity, the velocity after the collision, is 20 meters per second. And these velocities are traveling in opposite directions. That's something we should pay full attention to. They are traveling in opposite direction. Let's assume this red line, this red line that I'm currently, this red wavy line that I'm currently creating here is our racket. It's our racket that they have mentioned. Nah? So the ball is approaching the racket, and the ball is also moving away from the racket. And the ball is approaching the racket at 15 meters per second, and it is moving away from the racket at 20 meters per second. So let's just use this. When the ball is the tennis ball is moving towards the racket, that will be our positive direction, and when it's moving away, that will be our negative direction. This means that our final velocity is now going to be a negative value. It's now going to be a negative. It's now going to be a negative value. So now let's solve the problem. Our solution. What are we looking for? We are looking for, what are we looking for? We are looking for a change in momentum, which is mass by the change in velocity, which is equivalent to, what's our mass? 0.06 kilograms multiplied by, what's our final velocity? Minus 20 meters per second, subtracting 15 meters per second. Minus 20 meters per second, it took this sign from the direction. And then now we will have a 0.06 kilograms by negative 0.35 meters per second. And our overall momentum will be, our overall change in momentum will be negative 2.1 kilograms meters per second. This negative sign is the overall direction for this moment, for the change in momentum. And we know that the direction of the net change, not the direction of the change in momentum of an object, is the same as the direction of the net force acting on the object. This shows us that the net force acting on this object, it is opposite to the direction of the object. Yeah, and this concludes our lesson on collisions.